Alright, y'all, today we're going to be talking about note card 28, the natural exponential function. So sometimes this is also called the Euler function. And we're talking about something that's y equals e raised to the x power. Now what is e? E is just, it's kind of like pi. It's a number that goes on forever, and the value of that is 2.71828 dot dot dot. Okay, so this is like saying 2.71828 raised to the x power. The way I remember the number, the several decimal places, I say 2.7 Andrew Jackson, because Andrew Jackson was elected in 1828, the year 1828. Okay, so let's look at the function itself to begin with. So just like any exponential function, a to the x, where a could be 2, 3, 4, 5, whatever. Okay, it goes like this. It increases very, very quickly. So as we go out towards negative infinity, the function approaches 0. So the limit of that as x approaches negative infinity would be 0. That's what this part's saying. Okay. But if you go out to the right, okay, it keeps going up and up and up forever. It goes up towards infinity. So the further we come out as we approach positive infinity, this is heading up towards positive infinity as well, which we know isn't really a number. So we would say positive infinity, comma, does not exist. And exponential functions, whether it's e to the x or any other number raised to the x, okay, they increase faster than polynomial or log functions. So increase very, very quickly. All right, they are continuous everywhere. There's no gaps. Okay. Monotonic, meaning it heads in one direction. The further you go out that way, and it heads in one direction as you go that way. Okay, and the inverse of e to the x would be natural log. So what does natural log curve look like? It kind of looks like this. That's a natural log curve, ln of x. Okay, so what's special about inverses to each other? Okay. If you flip this curve over the line y equals x, it gives you this curve. So for example, the point 0, 1 on the Euler curve has an inverse point of 1, 0 on the natural log function. Okay. Now before we get into the derivative of this thing, I want to review just regular exponential functions real quick. So we saw in a lesson previously, if we have, for instance, y equals 5 to the x, we have a rule to help us figure out what the derivative is there. So here's what we would do. To figure out y prime, here's the a value. So let's write our rule down again. Here was the rule. If y equals a to the x, then y prime equals ln of a. Okay. Actually, that wasn't the rule. If y equals a to some u, where u is some function of x, okay, to find the derivative, we take the natural log of the base, so ln of a, times the original entire function, so that's a to the u again, times the derivative of u with respect to x. So that was the general rule. So here, the base is 5. So when we take the derivative, we need an ln of 5 at the beginning, times the entire function itself, again, which would be 5 to the x, and then times the derivative of the exponent. So what's the derivative of x? Well, it's just 1. So in this case, y prime would be ln of 5 times 5 to the x power. So let's apply that same rule here. So let's say that y equals e to the x. Remember, e is just a different number than 5. E is like 2.71828. Okay, so this is an exponential function right here. This is an exponential function. So if we use the same rule, okay, this is our base, it's just a number. So we start with ln of e, right, times the entire function, which is e to the x, times the derivative of the exponent. Well, the derivative of the exponent in this case is just 1. So something special happens with this. Natural log of e, these things are inverses to each other. So this cancels out or simplifies to 1. And then here at the end, if I multiply something by 1, it's just itself. So if the function is e to the x, the derivative is actually exactly the same. So that is how we get this rule. The derivative of e to the x is simply e to the x. Now, what about if this isn't simply an x? Let's change it a little bit. All right, let's say that y equals, let's say it's e to the 5x squared power. E raised to the 5x squared power. So using that same rule as before, here's your base. So we would put an ln of e in the beginning, okay, times the entire thing, that's e to the 5x squared again, times just the derivative of the exponent. The derivative of 5x squared would be 10x squared. Again, ln of e simplifies to 1, so that goes away. So here, y prime would equal 10x squared times e to the raised to the 5x squared power. Or it's not 10x squared, excuse me. The derivative of 5x squared is just 10x. Apologies, it's just 10x. Okay. So that's how we get this rule right here. If it's e to something other than just x, you take the derivative of the exponent, that's where I'm getting the u prime, times the entire thing. And why am I leaving off the ln of e? Because that simplifies to 1, so we don't even have to write it in there. All right, so let's practice with several problems here. Okay. So number 1, it says find the derivatives. Okay, so our rule says u prime, here's the u is the exponent. What's the derivative of that then? Hopefully you know that the derivative of 2x minus 1 is simply 2 times the entire thing again. And that's it. And let's look at the next problem. Now, what do you notice about this here? This is a quotient. So if I want to find the derivative, I have to use the quotient rule. So we say low 2x d high, the derivative of high, so the derivative of this, okay, we have to use this rule up here. It says u prime, so the derivative of 2x is just 2 times e to the u again, so e to the 2x again. So here's low, this whole thing is d high, derivative of high, minus high, that's what's on high. D low, what's the derivative of 2x? It's just 2 all over low squared. Now on just my notebook paper, I'm going to simplify that. So here's what I have so far. All right, I have f prime of x equals 2x times 2 times e to the 2x minus e to the 2x times 2 all over 2x quantity squared. Okay, so if we want to simplify this a little bit, this would be your first line answer. Okay, but if this is a multiple choice question, we have to know how to simplify. Okay, if this is a free response question, you can leave it like that. 2x times 2, that's 4x, times an e to the 2x, okay, minus, I can just move that 2 in front. Okay, and if I want to square this, that means I have to square the 2, that's 4, and I have to square the x, that's x squared. Now you could do a little bit more factoring. Between 4 and 2, they have a common 2 as a factor, and they both have an e to the 2x, so I can also factor that out. Okay. So I have a 2e to the 2x being able to be factored out. So 2 goes into 4 2 times, and there's an x in there that we need. And here, we've taken out a 2, we've taken out the e to the 2x, so the only thing left is a 1, and you've got to put that 1 in. All right, all over 4x squared, and you can simplify the 2 over 4 into 1 over 2. So the simplified version of this answer is e to the 2x times the quantity 2x minus 1 over 2x squared. Do not try to cancel this x with one of these, okay, because there's a minus sign in here. If these were all times, you could, but there's a minus in there, so you can't go any further. That is the derivative. Let's look at question 3. If f of x equals e to the x, which of the following is equal to f prime of e? So these are all limit statements, so I need to use the definition of derivative at a point. And of the 3 options, I always see the limit as h approaches 0, so I just have to concern myself with that definition. So let's go back to definition of derivative at a point. You can kind of see through the paper there, so I'm going to use a new piece here. So definition of derivative at a point. So we have 2 definitions that we can use. We can say that f prime of a, and a is some number, equals the limit as h approaches 0 of f of a plus h minus f of a over h. That's one definition. Or the other definition at a point, f prime of a, is the limit as x approaches a. See how those are different? One's h approaches 0, the other is x approaches a, of f of x minus f of a over x minus a. Okay, so let's think about what we're given here. They tell me that the function is e to the x. Okay, and they want to know what f prime of e is. So here, this e is the a value. So if I want to start to write out the definition here, the limit as h approaches 0, okay, of f, okay, here it says a, well, what's the a value? It's e plus h. minus f of e again, all over h. So let's figure out what these things are. Okay. Let's figure out what f of e is. How am I going to find f of e? Everywhere I see an x, I'm going to plug in e. So that would just be e to the e, which is fine. What is f of e plus h? Well, everywhere you see an x, instead of plugging in an e, you're going to plug in an e plus h. So this would be e raised to the e plus h. So now if we simplify that one even more, we get f prime of e equals a limit as h approaches 0. What did we say f of e plus h was? It was this thing, e raised to the e plus h power, minus, what was f of e? It's e to the e, all over h. So by definition of derivative, the first one, that is a correct answer. Okay. And what does that match up to? It matches up to letter C. Now, none of these options has an x approaches a. It doesn't have an x approaches a here. But if it did, let's go through the other example just to build our own knowledge and feel more comfortable. Okay. So here again, they want to know what f prime of e is. So the a value is equal to e. So everywhere I see an a, I'm going to plug in e. Okay, so this would be the limit as x approaches e. Well, here there's an f of x. What was f of x equal to? It just equaled e to the x. So I can substitute an e to the x minus, what was f of a? So in this case, remember a is e. What's f of e? It's e to the e, all over x minus e. So this would be the other way we could have written the derivative at that value using that definition. But this answer doesn't occur. Okay, but this is also a valid answer. All right, but it's not available to be selected. Okay, so these would be the two ways we could write the definition of the derivative at that point. Okay, let's do number 4. It says, let f be a function given by this, and let g be a function given by this. At what value or values of x do the graphs of f and g have parallel tangent lines? Well, what do we know about tangent lines? Tangent lines, the slope of tangent lines, okay, so let's just write some notes to ourselves. The slope of tangent lines equal derivatives. The slope of tangent lines equal derivatives. Okay, and what does it mean to be parallel lines? So parallel lines means they have the same slope. Okay, parallel lines have the same slope. So basically, when are these two functions, okay, going to have derivatives that are the same? Where are the derivatives going to be the same? So what we have to do here is we have to figure out where is f prime of x going to be equal to g prime of x. That's what I'm trying to find. Where is f prime of x going to be equal to g prime of x? Well, what's f prime of x? Let's figure that out. F prime of x, the derivative of this, the 3 is a coefficient, it stays. And what's the derivative of e to the 2x? Well, we take the derivative of the exponent, which is just 2, okay, times the whole thing again. And if you simplify that, 3 times 2 is 6. So the derivative there is 6e to the 2x. And what about g prime of x? Well, g is just a polynomial. Power rule, 6 times 3 is 18. Reduce the power by 1. So what we want to do is we want to figure out where is this equal to this. What value of x does that happen at? Okay. So here we want to figure out where 6e to the 2x is equal to 18x squared. Now this is a calculator question. You can't do this algebraically. You don't know how to. Okay. But I could put this into y1 in my calculator, and I could put this into y2 in my calculator, and I could figure out where they come together. So that's what I'm going to do. So going to my calculator, I have 6e to the 2x. Put that in y1. I have 18x squared. Right, and I'm just going to go zoom standard to see if that gives me an idea. Okay, so there's the first one. And there's the second one. So here's the exponential function right there. Okay. There's the exponential derivative, and here was the parabola derivative. To me, it looks like they come together right there. Okay. They come together right there. And we know the red curve is going to go up quicker than the blue curve, so they're not going to meet again. They're only going to hit in that one spot. So if I go to second calculate, let's calculate the intersection. When we get close to the intersection, I'm going to hit enter on the red curve, get close to the intersection on the blue curve, and then I'm going to hit guess. So I'm going to hit enter all 3 times. So what does it tell you there? What's the x value where they intersect? Negative 0.391. Okay, so the x value is negative 0.391. And if you were to plug that in here and plug that in there, these should have they should be the same values. The actual value here, they would both have y values of 2.747. Okay. So at that x value, they have the same slope. Here's a way you can confirm it. Go back to your original functions. Okay. Go back to your 3e to the 2x. Okay, and your 6x cubed. Do these have the same derivative at an x value of negative 0.391? So if I go to second calculate, choose option 6, and I type in, it says calculate the derivative at a point at negative 0.391, the red curve has a derivative of 2.745, roughly. If I do the same thing with the next curve, I'm going to switch to the y2 there. I'm going to go calculate the derivative at a point, negative 0.391. Right there, it has a slope of 2.75. Now, why were they a little bit off from each other? Because of rounding error. I only used 3 digits here, negative 0.391. Okay, but roughly they have the same slope, both spots. Another way you can kind of see that, if I quit out of here, if I want to draw a tangent line to y1 at an x value of negative 0.391, it's going to turn the graph into something blue. So there's the tangent line to the first curve. If I do the same thing, but do it on the next curve, Don't these two tangent lines look parallel? They look pretty parallel to me. Okay. At that x value, they would have parallel tangent lines. All right, let's keep going. So number 1 here, it says differentiate y equals 3 raised to the e raised to the negative 3 over x. I might choose to rewrite this. This means e to the negative 3 over x. I could write it like that. And if I want to switch things around, okay, I could also write that as e raised to the negative 3 to the x to the negative 1 power. Why write it like that? Because it's going to be easier to take the derivative. Okay. So if I want to find y prime, I'm going to take the derivative of the exponent. So I have to use power rule here. Negative 3 times negative 1 is positive 3. I got to reduce the power by 1. Okay, so that's the derivative of the exponent times the whole thing again. E to the negative, I can rewrite it like that if I'd like to. It's not a big deal. It means the same thing as that. And if I wanted to make this a little bit nicer, I could put the 3 over the x squared to start with times e to the negative 3 over x, or I could even write this as 3e to the negative 3 over x power all divided by x squared. And that would be the derivative. Let's try the next one. Find the instantaneous rate of change. What does that mean? It means slope. So I want to find f prime at that x value. I want to find f prime of 0. Before I can find f prime of 0, I first have to find f prime of x. So I got to look at f of x, and I have to see what I have. That's a product. I need to use product rule. Derivative of the first term, so the derivative of e to the x is e to the x again, times the second term, which is cosine of x. Okay. Product rule is always a plus, plus the first term, which is e to the x, times the derivative of the second term, which is negative sine of x. So if I wanted to rewrite this, I could factor out the e to the x, because they both have one, and then I would have cosine of x minus sine of x. So that's the derivative for all of x. Now I want to figure out what f prime of 0 is, so everywhere I see an x, I'm going to plug in 0. Okay, well e to the 0, anything to the 0 is 1. Cosine of 0 radians, or 0 degrees, that's also 1. Sine of 0 radians is 0. Okay. So 1 minus 0 is 1, times 1 is 1. So there we go. That's the instantaneous rate of change at an x value of 0 to the original function. Right, number 3, good review question. It says a particle moves along a horizontal line, so this is its position function. Okay. Find when the particle is at rest. Well, what does that mean? That means when the velocity equals 0. That's what it means to be at rest. Okay, so what is velocity? Velocity is the derivative of position. So let's rewrite the position function as something a little bit nicer. S of t. Well, this is just dividing by 3, which is the same as multiplying by a third. So we have 1/3 times t squared times e to the 3t. So to me that looks like a product, so I'm going to use a product rule. Oops, wrote that wrong. So velocity is the derivative of position, so here's my first term, 1/3 t squared, and my second term is e to the 3t. So derivative of the first, 1/3 times 2 is 2/3. Reduce the power by 1. Okay, so 2/3 t is the derivative of the first term, times the second. Product rule is always a plus. Product starts with P, plus starts with P. Okay. The first term, 1/3 t squared, times the derivative of this. Well, what would the derivative of this be? The derivative of the exponent is simply 3 times itself again, e to the 3t. Okay. So in this case, a 1/3 and a 3 knock each other out. Now, can you factor some stuff out? You could. Okay. They both have at least one t in common, and they also have an e to 3t in common. So I could factor out a t and an e to the 3t. Okay, so I factored that out, I have 2/3 left there. Plus, I factored out e to the 3t, and I factored out one of these t's, so there's still another t left. So what I have to do is I have to figure out where does that velocity equal 0. So there's a few terms in here. There's this term, there's this term, and there's this term. So if this parenthesis equaled 0, 0 times anything would also equal 0. So at time 0, the particle is at rest. Now the next term, e to the 3t, if you remember what the exponential graphs look like, this can never equal 0. Okay? E raised to the 3t will never equal 0. It will always actually be a positive number. Okay, so there's no solutions to that part. Okay, and lastly, 2/3 plus what would give me 0? Well, it's negative 2/3. Okay. But this signifies a negative time. Negative time doesn't exist. So I'm going to eliminate that answer because there's no such thing as negative time. So the only time when the particle is actually at rest is at time t equals 0. Going on to number 4. Here's my function. It says find the derivative. So if you notice here, this is a product. E to the 2x is the first term, sine of 3x is the next term in the product. Okay. So I want to find h prime of x, I'm going to use product rule. So the derivative of the first term, derivative of e to the 2x, we'd have an e to the 2x times the derivative of 2x, which is just 2, times the second, which is the sine of 3x, always plus with product rule, the first term, times the derivative of the second. But how do you do the derivative of this thing? You got to use chain rule. So the derivative of the outside, which is sine, the derivative of sine is cosine. We don't change the inside. Okay. Times the derivative of the inside. Derivative of 3x is simply 3. And if we wanted to make this look a little bit nicer, what do these things have in common? They have an e to the 2x in common. We could factor that out. And if we do that, what's left? We have a 2 sine of 3x. I like to put parentheses around the 3x because that's the argument of the trig function. Plus, we've already taken care of that by factoring. We have 3 cosine of 3x left. So there's the derivative function. All right, number 5. Again, it's asking me to calculate a derivative. What do you notice? This is a quotient. It's a quotient, so you can use the quotient rule. Or if you would rather use the product rule, we can write this as tangent of 2x times e to the negative 3x. Okay, we can move this whole thing to the numerator by making the exponent into a negative exponent. Either way you want to do it is fine. Okay. Since it's a quotient and we probably need more practice with quotient rule, I'll do it using the quotient rule. Okay. So quotient rule says low, so that's low, d high, derivative of the high. So how am I going to find the derivative of tangent of 2x? I have to use the chain rule. So the derivative of the outside is secant squared. We don't change the inside. Times the derivative of 2x. Okay. So there's your low. There's your derivative of high. Quotient rule requires a minus. Minus high, that's what's high. D low, derivative of low. So what's the derivative of this thing? Well, the derivative of 3x is 3 times e to the 3x again. All over low e to the 3x squared. But instead of writing squared, I'm going to write it just a second time. And you'll see why in a second here. So if we do some simplifying, this is a first line answer. If we did some simplifying here, we could factor out the e to the 3x because both of these terms have an e to the 3x on them. Okay, so if we do that, we factor out the e to the 3x, then I would get, what's left? 2 times that, so 2 times secant squared of 2x, minus, we factor the e to the 3x out, so we have 3 tangent of 2x left. Now in the denominator we have e to the 3x times another e to the 3x. If we actually want to simplify this, this e to the 3x will cancel one of these. So what's left on my paper, that's probably as far as they would take it. It's probably as far as they would take it. All right, number 6 is a tricky one. It says, at what point, so we're looking for an xy pair on the curve of this thing, is the tangent line parallel to this other line? So what do we know about parallel lines? Just like on the front, parallel lines have equal slopes. Okay. So if we rearrange this equation down here, subtract 5 from both sides, add y to both sides, we would get 3x minus 5 equals y. What's important from there? And I can again write this as y equals 3x minus 5. What's the slope of that line? Hopefully you can see right away the slope is 3. The slope is 3. So the slope of this line is 3. What does slope mean to this? What's the slope of the tangent line? Well, to find the slope of the tangent line here, we would have to know that slope is derivative. All right, so we would have to calculate y prime first. Derivative of 1 is simply 0. Derivative of 2e raised to the x, 2 stays, and the derivative of e to the x is still e to the x. All right, minus what? Derivative of 3x is just 3. So that's what the derivative function is. I need to figure out where is this derivative function equal to the slope over here. I need to set that equal to 3. So we could put this whole thing into y1. We could put this into y2 and figure out what x value they come together at. That's one way to do it. I'm not going to do it like this because even though this is a calculator question, you don't need a calculator to do it. So let's solve this. Let's add 3 to both sides. So add 3 to 3, you get 6. And then we can divide both sides by 2. So now I'm at e to the x equals 6 divided by 2 is 3. All right, now how do you solve this for x? Well, if you want to get rid of an e, you put ln in front. So the x value is ln of 3. So I found the x value of the point. How do we figure out the y value of the point? We would plug this in everywhere we saw an x. Okay, so the y value is going to be 1 plus 2e raised to the x, but x is ln of 3, minus 3 ln of 3. We can make that look a little bit nicer. 1 plus, what do you notice about e and ln? If you have e raised to ln, they cancel and you're just left with 2 times 3, which is 6. Okay. Minus, you can leave it like this if you'd like, or you can choose to move this 3 right there as an exponent. Okay. So 3 to the third would be 27. So 1 plus 6, you can add those together, it's 7. So 7 minus ln of 27. Okay, and I can't go any further than that. So my final answer here, without even using the calculator, at ln of 3, comma, 7 minus ln of 27, that's the point on this curve where if I drew in a tangent line, the tangent line would be parallel to this line. Let me get a decimal approximation for this. Okay, ln of 3 is 1.0986. And 7 minus ln of 27 is 3.70416, roughly. This is the exact answer. Okay, I like that one a little bit more. Okay. Let me put in the original function here into y1. 1 plus 2e to the x minus 3x. So here it comes. That's what the function looks like. So let's calculate the derivative at this point. Okay, so if I just hit trace, for instance, and I type in 1.0986, you should see the point on the curve here is 3.704. Okay, so I know I got the point there. If this is the correct answer, I got the correct x and y values. But if I go second trace and go down to option 6 and type in that 1.0986, if I hit enter, what do you notice about the derivative there? It says 2.9999273. The slope there, if I drew in a tangent line there, it would have a slope of 3. If I actually want to do that, draw in tangent line to y1 at an x value of 1.09. Actually, if I wanted to be exact, I know what the exact x value is. It's ln of 3. Gotta hit enter, sorry about that. So here comes the tangent line. Okay. Then here was the other line. Remember, we could rewrite that as y equals 3x minus 5. Let me do that in a different color now. So here comes 3x minus 5. And to me, the blue tangent line to the curve and the green line are parallel to each other. Okay. So I verified it using the calculator there. All right. So let's try number 7. It says if f of x equals e to the x times g of x, where g of 3 equals 2 and g prime of 3 equals 5, find f prime of 3. So that's my goal. I'm trying to find f prime of 3. I'm not going to worry about this stuff right now. I'm going to worry about, okay, what's my process to figure that out? Before I can find f prime of 3, I need to find f prime of x. Okay, so notice f of x is a product, so you got to use product rule. Derivative of the first, derivative of e to the x, is e to the x times the second, which is g of x, always plus, okay, the first, which is e to the x, times the derivative of the second. So the derivative of g of x would be called g prime of x. And if I want to find f prime at that x value of 3, everywhere I see an x, I'm going to plug in 3. So that would be e to the 3 times g of 3 plus e to the 3 times g prime of 3. So I notice right away both terms have an e to the 3, so I could factor that out. So it's just e to the third power times the quantity g of 3 plus g prime of 3, and then I can plug in the numbers they give me here. So if I do that, g of 3, it tells me, is 2, plus g prime of 3 is 5. If you simplify that, 2 plus 5 is 7, times this, it's just 7e to the third. Remember, e is just a number. It's 2.71828. But this is the exact answer. Okay, this would be a non-calculator question, so that would be the right answer. All right, so those are the examples that we went over on your packet tonight. Okay, on this first page, you just got a lot of practice with e's raised to different things. Okay. Think about number 6 here. You could do this one of two ways. You could actually treat this as the first and this as the second term, or you could distribute the e to the x. It doesn't really matter. So you could say e to the x times x plus 2e to the x. I think it's harder actually doing it this way because you're going to have to do product rule on this anyway. And the next problem, similar to the last one, here you can use quotient rule, or you can move this e to the 2x up to the numerator by turning it into a negative 2x and doing a power rule. On number 9, kind of interesting, remember your rules of powers. You can do this one of two ways. E to the 4th is just a coefficient. So you could write this as e to the 4th power times e to the x. This represents just a number. Okay, so that's one way to do it. Or you could say, okay, if you put these things together, remember if you have x to the a times x to the b, that equals x to the a plus b power. So you could have rewritten f of x as e to the x plus 4 power. Doesn't really matter. On this one, I'd probably rewrite this f of x as 7 times e to the negative 4x. It's going to be easier to take a derivative. You could use the quotient rule, but it's going to get you the same answer. So quotient rule would be more painful. So just some tips on that page. Okay, and on the back, more work with E here. Okay. Now on these questions, you can use your calculator, especially like for this one when you have decimal answers. Okay. And on this question down here, decimal answers. But I do want to see some level of work. I want you to see. I want to see you working out at least portions of this without the calculator. And that's where I'm going to stop the video today. So thanks for watching About E.